So I'm Jeremy Warner, and I'm going to be presenting ElectroTutor, test-driven physical computing tutorials. So this talk is centered around tutorials for electronics and physical computing projects. Online DIY electronics project platforms are booming, evident through vibrant communities on Instructables, Arduino Project Hub, and Tinkercad. Users engage with these platforms to share projects, follow tutorials, and develop their skills. Here's an example of a typical Instructables electronics project. At best, users simply scroll through the steps and maybe watch a video demo. What if we could embed checkpoints to improve the overall tutorial experience? This could be by verifying knowledge of the specific step instructions or short-circuiting common errors. So for a moment, just consider this graph where the y-axis is progress and the x-axis is time. The ideal case has progress going up and to the right, but the reality is that while novices sometimes follow these tutorials okay, they often struggle with static tutorials. For example, a novice user might stumble over some configuration issues with uploading code to their board, actual software errors, or miswiring a hardware peripheral. This presents an opportunity to increase user learning and improve tutorial completion rates. So some additional challenges. A common novice pattern is to avoid incremental testing before the tutorials end, which makes scoping issues much harder. Additionally, while there are complex and open source like tools for debugging, they often have a large cost, like if it's a logic analyzer, or a steep learning curve on how to use them effectively. Additionally, these debuggers are often general purpose and content agnostic, which weakens their ability to guide novice users into where they should actually look to solve and address their issue. So there is solid related work in this area of supporting novices with electronics projects, including YFROS, which is up next, which enables visual network debugging, trigger action circuits, which was at WIST last year, that let users specify desired system inputs and outputs to design new systems, and the Smart Makerspace project, a tabletop application for guiding users through construction tasks. ElectroTutor differs by providing reactive tutorials for physical computing projects specifically. Also related is test-driven development, which we drew some inspiration from, specifically by this notion of incremental testing with specific test cases that address specific parts of the system behavior, and this notion of like mitigating fear and inspiring confidence to people that are doing the development. So to support novices, we built ElectroTutor, which integrates test-driven development with physical computing tutorials. ElectroTutor consists of a software interface with tutorial instructions, an Arduino-like code editor, an IDE, and a pane of interactive tests for each step. There's also a simple hardware probe that is used to physically measure the system's behavior. So here's a high-level overview of the ElectroTutor system. Tutorial content gets rendered and can interact with the hardware components through a backend server over communication ports. The tutorial content itself is represented in a simple YAML text format with each step's content rendered as Markdown, which enables easy code snippet and media file referencing. So while we were developing this, we also found a few interesting dimensions of tests that I'll bring up. So this test taxonomy consists of test setup, test verification, and the test domain. So the specific cases in each are automatic setup, which could be software instrumentation that's performed automatically, manual setup, which may be an example of which would be attaching physical probes to your device, or no setup at all required. Verification, similarly, is either automatic, such as a trace analysis that's run to determine correctness, or manual, like asking the user to see if a light on their system is blinking. For the specific domains that we're interested in testing, we have hardware, such as like the development board, code and knowledge about the tutorial itself. Next, I'll go through how ElectroTutor leverages this text taxonomy with examples. Specifically, I'll look at tests in a tutorial for building a light-sensitive alarm clock, which basically means when a sufficient amount of light is detected, like from a flashlight, the alarm goes off and it can be reset by pressing a simple button. So one test is a runtime hardware test. So to test dynamic behavior of the system being built, the user is instructed to insert test probes into their circuit. This test can confirm the voltage is expected when the button is pressed. So a similar one is a runtime code value test. So in this test, the user checks to see that a value of the variable in their code matches the expected value when a light is shown on the sensor. So to achieve this, the system automatically instruments the user's code to send runtime data from the development board back to the tutorial system. Another test is a wiring test. So in this step, the user is instructed to connect a LED ring to the development board. To test that the user has wired the components correctly, they're prompted to load preset code that tests the ring. So similar to a example code that would ship with a specific peripheral, but it lets the user isolate the program or the system behavior to a specific part of their project. So other checks can serve similarly, like periodically checking for compiler errors. So here the user is prompted to check that their code compiles before advancing to the next step. So this can help address some incremental testing and prevents users from getting to the end of the tutorial and finding out that they're all facing a multitude of issues. So additionally, there's kind of less performance and more knowledge-focused tests. So this is a code selection test where the user is instructed to select a specific line of code that is responsible for some of the system's behavior. In this case, activating a buzzer alarm. The user selects the wrong line and is given a tip on addressing this issue. So here, they can then highlight a new line of code to test that. So it's a different way of interacting with the user about what their code's purpose is. Additionally, there's the kind of a knowledge test that is a more flexible way of addressing some knowledge about the tutorial process, like a simple multiple choice question. Again, this gives a contextualized opportunity to provide corrective feedback to tutorial users. Okay, so we're interested in seeing how ElectroTutor would shape participants' usage patterns, knowledge retention, and subjective experiences while working with the tutorial. We designed a study consisting of a brief demo with a maximum of 45 minutes to complete the tutorial, followed by a survey and informal interview with each participant. The survey included 4 quiz-like questions about the tutorial's content. Here's the evaluation setup. The software consisted of the tutorial interface, and participants were provided with all of the required hardware for building the tutorial project. There are 2 research conditions, specifically ElectroTutor, where tests are enabled and you have to pass them to progress on to the next step, and a control case where there are no tests provided and no progress restrictions. While this test difference exists, both cases worked on the same project tutorial and had all the same instructions. So for our participants, we had 12 total, did a between subjects study, and none of our participants had any background working with electronics prior to this. The project that they actually worked on was the light-sensitive alarm clock that was pictured earlier. This tutorial included 24 tests spread over 16 steps. Next, I'll go over some of the results from the study, including metrics of completion, timing, knowledge, and back steps, so some progression patterns that the users exhibited, or participants exhibited. So for completion, the max was 6 because there were 6 participants in each case. So 5 out of 6 in the ElectroTutor completed it, whereas 3 out of 6 completed it in the control condition. This is not statistically significant, but so additionally, we measured timing. So while these are also comparable, the ElectroTutor participants had to work through 24 additional tests to finish, and also 5 out of 6 participants finished. So that's something to note. We also had a question about knowledge. So we presented a 4-question quiz about the tutorial's content after. While the ElectroTutor group did score higher than the group, this is not quite large enough to be significantly different. And one last quantitative measure we explored was back steps. So going back to the early example that I showed before, consider these examples of progress and time. Here are 2 different yet kind of stereotypical cases of traversal through the tutorial. The orange line progresses smoothly, while the blue line frequently returns to previous steps, revisiting them in order to complete the tutorial. And here's the overall pattern. So the top case with the orange lines is ElectroTutor, and the blue is the control case. And overall, we found that participants performed significantly less backtracking when they were using ElectroTutor. So in addition to these quantitative metrics, we also gathered qualitative feedback from participants. So here's some comments from participants in the ElectroTutor condition with tests enabled. It's fun making things happen. I was never good at electronics in university, so it's fun and it breaks it down really nicely to make sure you feel very comfortable where you are before you go on to the next thing. Another participant said, the tests were definitely helpful. I especially like the fact that tests were done in a granular manner at each step along the tutorial, so that I felt confident throughout the tutorial. Contrastingly, here there are some quotes from participants in the control condition. I struggled with the hardware part. I was not that familiar with it. It's kind of like I'm following instructions, but I'm just not sure if I'm doing it the right way. It did a good job of guiding me to successful completion, but did not really educate me on what I was doing. So we also have some ideas about future work. One is tutorial authorship interfaces. So ElectroTutor primarily focuses on tutorial followers rather than authors. So providing ways for content creators to integrate these checkpoints is a good direction. Additionally, activity review dashboards for authors. So this would be visualizing tutorial usage, potentially encouraging some revision of ordering or content based on these usage patterns. Another is skill-aware dynamic tutorials. So this might be if there are users that have different levels of skill, maybe providing different levels of support would be helpful to reduce some of the overhead that completing tests gives. And lastly, supporting formal learning. So this is ElectroTutor is concerned with projects and tutorials for electronics, predominantly like ones you would find on Instructables, but better supporting learning in classrooms where there's a different set of incentives. It would probably require a different system. So some acknowledgement, thanks to my collaborators, the Autodesk User Interface Research Group and David Mellis. And so yeah, I've presented ElectroTutor. This is ElectroTutor. We have incremental tests, and they aid novices in problem scoping. Preliminary work points towards potential for improved tutorial completion rates. And I am happy to take any questions. Thank you.
Yeah, please grab the, so many people already lined up. That's great. Yeah, go ahead.
Hi there. I'm Holger Winnemüller from Adobe. Great work. I was wondering, you mentioned the kind of step backs, and it kind of sounds like that's a bad thing, except for there can be learning that happens in those back steps and connecting the failures to what you need to do to improve the performance. So I was wondering, do you have any idea of comparing your system where you're kind of telling people how to debug the system versus making them learn how to debug the system themselves, which is a useful skill in itself?
Sure, I do agree it is a useful skill, and there's a kind of balance between telling the user how to exactly solve all of their problems and promoting this kind of like concept of learning and skill development. Because we were focused on mainly avoiding the case where novices go through an entire tutorial without any testing and then get to the end and then basically fail because they don't get skill retention and they don't complete the tutorial. So our goal here was to provide incremental testing primarily for supporting tutorial completion, but also I think there is a different main design concern is, okay, well, if we want to do skill development, maybe like a classroom learning or a course where the focus is learning, that I think is much more of a concern, and I think it's a valuable one as well. So thank you.
Thank you.
One question from the left.
Hi, I'm John from Google. I have been doing test-driven development in the software world for a long time, and one of the principal tenets there is that you write the test before you write the code. And I was wondering if you had any thoughts on perhaps running the tests before implementing the hardware as kind of a motivation.
I see. So maybe doing some. In the tutorial structure, we did have a compile test before uploading to it. So in that way, there is, I guess, trying to verify that the software works before loading it onto the hardware. And I think that the development part is a little bit different, right? Because that's for people kind of creating some new thing that's not following a tutorial in general. So we kind of drew some inspiration from it, but I don't think there's like an exact match to all of the test-driven development philosophy.
All right, let's take one more question while the next presenter is plugging in.
Thank you.
Maybe want to step a little bit.
Cool. Laura Olberg, University of Calgary. One question is that when you had people go through the condition where they had these tutorials and they're being scaffolded as they're doing these tests, did you see any inclination that they learned that those tests were good and learned how to do their own tests when they reach that control condition where there's no longer that scaffolding of when to do those kinds of tests?
Maybe I misunderstood the question. So there's the control and ElectroTutor conditions where they only did the tutorial once.
Okay, but did you see any evidence that after they went through the tutorial that they recognized that the testing was a valuable skill in itself? So besides being part of the tutorial, something they could integrate in their own practice.
Oh, I see. So a reflection on their perspective of the value of testing after. I think it came up a little bit in the interviews, but we didn't have an explicit question that prompted people about that, though.